see it. And so let me, okay, Ari, can you see my screen?
I can see it.
Okay, so we're good then. So we're going to go ahead and launch this lab, uh, and we'll go step by step.
So are we gonna do yours first, or do we try to do it at the same
No,
time?
I'm gonna run. I'm gonna run it, and you just watch me, and together, I want you to talk because I know you already try to work it. So just watch me work it,
Okay.
and then of course later on, of course you of course more than welcome to work it yourself.
Okay. Well, since I'm watching you, I'm gonna switch it back to my computer.
Okay. Yes. Okay. Yes.
I thought we were doing it at the same time. I
Uh-huh.
can switch back. It's easy. It's just a
Okay.
click.
Good. That works.
Okay, I'm back.
Okay. So let me try to get this thing up. Okay. So we're starting here. So you're setting up a computer and laptop for users at the company. Uh, Structurality. Today, you are configuring a web development server for the user can. The server computer has been brought onto the company's network site for configuration and testing, but will eventually be installed to the user's home network. You need to verify that the Linux operating system installed on the server has been configured with appropriate desktop tools and a command line shell. The command line is just that black window that you get in Windows, but here we're working with Linux today. Use the desktop tools, which is what we're seeing here on our desktop, uh, shells to operate computer running the Linux. So note that type text is not available. Okay, so I've read some of the instructions. So I'm going to say next. So that can be opened entirely on the command line, but it's also possible to install on desktop. Okay. Now, okay, so notice that the account was signed automatically. You did not need to enter a password. Okay, so we got in automatically. So the panel on the left is the dock. So this is the dock here. From the dock, select the show application. So let's go look for show applications
It's
here.
it's right there on the left. You know where you click show applications?
Yeah,
You
are
just
you
go
seeing?
right above on the left, right above Firefox.
I'm
Up,
not,
up,
are you seeing the screen with the applications? Are you seeing?
all the way to the left.
Right.
Remember you click,
Yeah, I've done that. So now the
yeah.
applications are showing on my screen. Can you see them?
Mm-hmm.
Okay. So from the so I did step one. I'm going to check it off. So from the dock, select show applications.
I'm
Uh,
sorry, you missed that step. See, on number one says select terminal.
yeah, right,
So you're
right.
supposed to open up terminal. It's right
Oh,
above the show applications.
okay, great. Thank you.
And then it wants you to go to show applications.
Okay.
So it wants you to leave the terminal running while you show applications. Mm-hmm.
Okay, and then it says the shows now number three. Scroll the page and then select this icon. So we're going to scroll and look for that icon. And if you see it before I do, please do let me know.
I think it's on like, do you see those three little dots?
Yeah, it's the second one, I believe.
I think,
It's
I'm
right
not
there.
sure.
Yeah, you're
And
correct.
then,
That's the text editor, right?
yes,
So we'll click on that. And now that opens. So I'm going to check it off our list right here. So now uh, I'll reposition my window again. So now we're here. So in the text editor, drag the window by the title bar to show the dock. Well,
If you make your, like, on the right side where the instructions are, if you make that narrower, it can show you the whole screen or more of the screen.
So they want me to drag this thing down. Well, anyway, let's just see what's it in the text editor. So we're in the text editor right now. Drag the window by the title bar to show the doc. Okay, well,
I think that's the part where you're supposed to click where it says Untitled Document 1 and drag it out the way.
top bar select activity. Okay, I'm gonna say that I did drag it because I did try to do that. I'm gonna check that off because if we're not seeing the other one,
There you go.
if I can drag it down. But anyway, we can see the other one. So I'm just gonna continue here. And then from the top bar, which is the activities up here, right? So the activity menu provides another way to switch. So I said, we'll go here and then select activities. All right, and then select activities again to cancel the menu. So we're just activities. I guess they're just having a practice what activities we'll do. We'll continue. Now we say from the top bar, click the system status menu. And the system status menu, I believe, Barry, if you see it before
I
me,
think I think it's the one,
it's a
not
drop
that.
down right there. It's confusing, but it's that drop down right there.
I don't.
And
Um.
then for system status menu, the view options,
Yeah.
you can see they want us to select settings. Okay, so here's settings. We'll select settings. And then we'll continue and then close the settings and text editor window, leave the terminal window. Okay, I guess they just want us to practice with settings. So we'll go
Yeah.
ahead.
It doesn't start getting crazy till we keep going.
Okay, so we did that. Now we know where some of these things are. I guess I just wanted us to see that. Now we'll go next. And now say Linux, the desktop environment does not provide access to all the configuration options. When managing a server computer, it is more typical to use the command line. It is worth understanding some of the underlying features of the command line for Linux. So we're going to go here now. So in the terminal app, type PS. So let me right
That's
here.
the text editor. We can close that one out too.
They want us
We
to go
don't
to
need
the terminal window. Okay, so
this is yeah, we can close this
I'm
one
going to
out.
minimize that, and this is
Okay.
the terminal window. So
There we
here
go.
they want us to do a PS, right? So I'm going to type in PS. That's a Linux command, and then just tell.
See, it's working for you. When
Okay,
I type PS, that where you put PS, it stays blank.
yeah, okay.
And I think that was one of the issues they said because they couldn't replicate the issue.
Oh, okay, so let's make a note of this one, and then we'll continue and see what other ones they gave you problems with.
Okay.
But we'll work it out so you at least get to see it. So semi worked out for you as well. So we did that, right? And then the output shows the processes that are running right now. And then we'll continue here, just telling us what it's doing. So now we go here. Now they want us to type another command and expand on it. So we're going to do a click here on the window again. So I had my cursor on the instructions. So now I click on the terminal. So I
Okay.
click there. So now I'm going to do a PS minus E, and then that symbol, Ari?
Mhm.
Okay, good.
Mhm.
And then it is G rep, and then minus V, and then we'll do a question mark. And we'll run through that, and then that gives us more processes that are running, and it tells us what are the processes that are running here. So we check that, and we'll continue. Now they want us to do press Control Alt F3 or the terminal window enter sudo. I'm not going to attempt the Control Alt F. I don't know if it will work. I'm just going to do the other option. which is typing the sudo. Sudo is just a Linux command saying that what I'm going to run in privilege mode, like in administrator mode. Sudo is like an administrator, sudo. And again, you're not here to learn Linux, but just so you can get an idea of what's going on here. And then they want chvt, and then 3, comma. So they're running this process in administrator mode, and then it's going to ask for a password. So when I press enter, it's prompting for a password. So I'm going to put the password that they want us to enter. So it's capital P A $$ W0RD, and it logged me in. I'm assuming it. Okay, sir, log in, and I think it's asking now for another password to enter again. So it took us to a different place. That's also secured, so they want a password. Again, I'll do P. Right, log in. Am I correct? Type CAM, C-A-M, press enter. And I was going to ask for a password for this user because earlier I got in as sudo as an administrator. Now I'm getting back as CAM. Okay, so again, it's P-A $$ W and then 0RD. Press enter. So it logged us in. We'll continue. Let me make sure I check here because it keeps you track. I missed checking the previous one or something like that. Okay. Okay, so we've done this so far. So now we did camp. So now they want to run a check on us. See, click the check and let's see. It's checking to see we've done things good to this point. Okay, so things are looking good. So now we're going to type, as they're asking there, PS again to, oh, I got to click on the left side now, my cursor. So I got to come in. PS minus E and then grep, get rep, minus V question mark. And then it gave us a process is running, and then the output lists the different terminals and shell instances. And we'll continue. Oh, let me do a check there. And now, again, they want us to do another process as the sudo account. sudo thvt 2
okay,
comma, put that, and then it's prompting for the password again as P A $$ W0RD. Okay, and it got us in. Leave the terminal window open. All right, and we go next. Explore features of the shell. The shell is where you put in your commands and all that. In the terminal, observe the prompt. Okay, so we're here in the terminal. So this is the prompt. This is that user CAM. That prompt is telling what user is on. So we observe that, identifies the shell type and all that. So it just shows at home server. And then on the terminal, run pwd. Pwd, it shows you where we are in our directory structure, what folder, where we are. Pwd. We're in a folder called home, called CAM. So it's like the home folder of CAM. Every user has their own home folder. In Linux, pwd could throw you off because if I don't know Linux and I look at pwd, that appears to be a password of something, but it's not. It's just showing you what directory are you located in. And that's what that did right there. And then ls just gives you a list of that directory. So we'll type in ls, and it gives us a list. These are the other folders that are in this directory. These are the subfolders that CAM has. So we did that, and then type in LSDE. This is not supposed to work, but it's an intentional thing they want us to do. LS and then DE, uh, and then press the tab, and nothing's happening. In Linux area, if you spell, let me just give you an example. If you spell the word cat in lowercase, CAT, and you spell cat with a capital C, CAT, in Linux, those are two different words,
Two different codes.
two different commands.
Okay.
And that's what they're trying to show us here. We try to do DE, but it's not a valid command. And then when you press the tab, it will finish spelling out the command for you. But it's not a valid command, so it's not going to do anything. So use the backspace to delete the DE. So we'll go backspace. Let me get on this side now. Backspace, backspace, and then we do DE. And now if I do the tab, it just spell out the entire command. It's just like a shortcut. That's all that is. See, it just spelled it out.
Okay.
Again, we're not here to learn Linux, but if you were working with Linux, it's just, you don't have to type all the letters. If you just type the first few letters and press tab, it'll complete the spelling for you.
Okay.
And then press the up arrow key. This subjects also, when you're working with Linux and you already typed some of the commands, okay, we did that, and then you tap and then press enter and do that. And now look, I'm gonna press the up arrow. It'll bring back previous commands that I typed. So if you have to type a previous command, you can just keep pressing the up arrow, and it brings commands that you've done previously. So that's what that does.
Okay.
And then so we press the up arrow, and now use left arrow to position the cursor to LS. And then use a delete to remove the command. All right. And then use the delete to remove the command, and then type CD and then press enter.
Is
All
it
right.
saying one should delete the LS too?
Yeah. So
Okay.
then you do a CD for change directory. That's what CD stands for, and press enter.
Change directory.
And then we did that. And press enter. So I check that. And then modify the previous command to run cd dot dot. Okay, notice that the directory we're in right now, we're in what, CAM at home server. Now
Yes.
cd and then dot dot should take us back. Let me see, cd space dot dot.
Oh, that's at home.
Okay, yeah, it backtracks to the previous directory. So it took us back to another directory, to the home directory, which and that's what that does. It just goes back to the previous directory. So if you're like 2-3 levels deep into your directories, it begins to backtrack just like you would in Windows. And then run cd / and then ls minus else. Okay, let's just see here. C cd / and then ls. Okay, and then ls minus l to give us a list, and it gives you a list of what's in that directory, that home server directory. So that's all that did. And then now they want us to run cd tilde. ls minus L, and then just gives you a different display. It takes some of the things off, and it just telling you to list what's in that folder, and it's just showing you here. By the way, again, you may not be a Linux person, but what you see over here, these are the permissions that have been granted to these folders right here. Linux does it differently. Like the R is to read, the X is to execute, and then you have W to write, and so on. D to delete. Okay, so we did that. We did this, and now type exit. So now they want us to get out of this. So EX IT, and then it takes us there. And then check to verify that you have run the command successfully.
Supervisor,
Yes.
Dwayne said he's trying to get into class.
Okay, let me see.
Okay, he's gonna let you in. Okay.
I'm trying to. Okay, let me. Normally it pops up and admit, and for the life of me, I don't know why it's not showing it to me. Show meeting layout. Oh, there it popped up now. Admit. There we go. All right, Braylon. We're gonna run the check. Ari, how it does the check periodically. So now it's doing another check for us. And as you can see, it's saying, okay, we're doing good so far. Dwaylen, we're working A plus Cyber Module 7. We're working that one lab, so we can see what kind of issues were coming up. And I know Ari's gonna.
Oh, good. Okay.
He's gonna try it on a desktop, hopefully, at the library, because on her system, she was having issues that it was showing a blank screen, and so far on mine, it's working fine. So we're at step 12 now. We're going to go
Okay.
here, and here says explore command syntax. Yeah, Dwaylen, we haven't started the lecture yet, so you're good. And by the way, I was going to send you the recordings, and I couldn't find them, and then I said, what's going on? And then I did a lot of research, and normally I have them record them to the cloud, and I was not able to find them. So I started thinking, and what I think that it did, it put them on my computer. So today I'll get them and I'll send them to you for Saturday and for yesterday.
Okay, thank you.
Yes, you're welcome. So anyway, and then we're continuing here with the lab. So now it says open terminal. So right here, this is terminal. I click on it, and terminal should open. So it opened. And then they want us to run a command. The command is what is ls? And then ls is list directory contents. That's what ls is. It will give you a list of the contents of a directory. What's in that directory? That's what it is. It's Linux. Like I was telling Mary, we're not here to learn Linux, but just so you can get an idea of what's going on here. So we did that, and every time you do a step, you check it off. And we go on now. They want us to run man. Man is the manual. If you need help, you can run man. Again, in Linux, man stands for the manual, for the manual of Linux. So let me see here. Man ls, and then it's just the manual of the commands. And of course, you just scroll down and you look for the command to get some help with it. It's like the help, but it pulls it out the manual that Linux has. And then to get out of this, then you would type in Q to quit. Right here, it has the message here. Manual page, and it tells you what you can type in. We're going to do the Q to quit. That's what they're asking for us to do. So we did the Q to quit. Now run ls. Now we're going to run ls again. ls minus L to list, and then greater than symbol here, and then dir.txt. All right, class. This command is list. Any idea what this greater than symbol represents, class? Any idea? I'm not expecting you to know, but it's good discussion here, or just to give you an idea, because this is also something that works with Windows. If I would just run ls minus L, it would display the list on the screen like it did earlier. If I do ls minus L greater than dir txt, instead of displaying what it displayed on the screen, it's gonna put that what was displayed on the screen in a file. That file is going to be called dir.txt. That symbol is called redirection. You're redirecting the output. Instead of going by default to your screen, it goes to a file right there. So if I press that, it went to that file, and now they say, and then cat is a command in Linux that will list the contents of a file. So I redirected the list to the file dir. Now we want to go in that file and see if that list is in there with the cat command. And up there, and the list is in there. It redirected the output to that file. So again, they're just giving you to run some of these commands. Like I said, if you knew Linux, you can understand what those are. Okay, then now they're having to run again a list again. ls minus L, and then documents. I got to be very careful here with my spelling, because in Linux, you see there the word documents, it's in capital letter, the D is capitalized. Well, capitalized word that you see there, documents, and if you spelled it well, lowercase documents, they're totally two totally different commands. Linux is case sensitive. And then we have that, and then we have dir again, that redirecting. And we have that, and then it redirected something to that file, dir. And now let's see what it put in there. We're going to do a cat to see the contents of dir file. And now you can see that's what it put in there. So it's just having you run basic Linux commands. I probably in the lecture when you did, when you did those modules, what is it, 3 weeks ago or something? Okay, so now we'll run ls again, ls minus L, and then again, documents. I got to position myself on the other window, so ls minus L, and then documents greater than, redirecting again to the file txt, and it redirected the output to that file. Now let's just see what the contents are of that file now. txt, and now you can see the contents are much less. It replaces what was there before. All right, so continue. Yes.
So for number 7, it said to run ls minus L documents and all the other things. Now, you did them on 2 separate lines. Would that make a difference in the results that we get?
You talk about like here, if you do one and then
and it did the right
semicolon. Yeah, will just allow you to do 2 lines in one pass.
Oh, okay.
But I'm breaking it up just for more clarity. I do one and then I do the other one. Because I know Linux a little bit, so I do that. But you could do this, you could do that, and then as soon as it ran this command, it would automatically then run the next one.
Okay.
That's all. It's just something that Linux, allows us to save steps. But yeah, but good observation though.
You're a professional.
So here now they're going to list something, and now they are looking at a directory called etc. That is an actual directory, etc. Linux holds things in that directory as well for the users, and that's what that directory contains. Everything that is listed there. And then again, you see a lot of data, right? They're showing you a lot. Now they say, well, if you don't need all that clutter because you're only interested in looking at something specific, you might not need all that output. So ls, and then at the etc directory, and then you say less, and then it gives you supposedly a condensed list. I'm pressing the, until it gets to the end here. It just pipes the output from the preceding command to a second command. And I'm trying not to run out of time here. You know how these things are timed. So now it says you check this. Yeah. So now it's saying use the down and up arrow to scroll through the content, and then press Q to get out. So let's see if it allows me to do that. And Q allow me to get out. So now leave the terminal window open. All right. And we go next. So now we want to look at account privileges. So now we're going to do ls boot. So now they want to look at the boot directory, ls boot, and that's what the boot directory contains. That's the contents of it. And then they want to do ls boot. And then in boot, there's another directory called EFI. And it positioned, it listed what was in this directory. EFI is a subdirectory of boot. And it cannot open the directory with permissions denied. Okay, so they're having you do this intentionally. So because I'm not an admin, and only the admins are supposed to get into those folders, because that has to do with booting up and all that, right? It's a sensitive place that you don't want just any user getting in there, because they can mess up your operating system. So CAM, we're working with user CAM right now, but CAM doesn't have the permissions. But whenever you do need the permissions, if you do need the permissions and you are a tech, for example, and you're operating as CAM, and you say, oh, I can't do that, but I can do that as a higher level of the user. So I'm going to work as sudo, because I do need to run that command. So CAM cannot run it. The account of CAM cannot, but a privileged account can. So that's going to be sudo. So I'm going to redo that command, but under a different user called sudo, or I'm escalating my privileges. Sudo ls now /boot /EFI. And now I was able to do it. Now it's asking for the password. 0RD, and now the password for CAM. Okay, so it sudo password for. So now, sorry, try again. Okay, let's just see here. P. Oh, I put the @ sign. Sorry, instead of the. I'm so used to using the @ sign when I do my passwords.
Once we do this, I do have a question.
Yes.
So let's say, for instance, this command that was run, and you know how we were under CAM's login,
Yes.
and then it says permission denied.
Uh-huh.
In our role in cybersecurity analysis or analyst,
Yes.
is this something that we would see, like somebody attempting?
Yes.
Let's say, for instance, it was Cam actually trying to do it and not an admin.
Correct.
Is that something that we would see and then kind of, like take action?
This is a common thing, because one of the things, and one of the lessons we discussed, that the administrator accounts, you don't want to use them for your everyday use. You want to use your account, and your account could have more privileges than a regular user, but it's not going to have as many privileges as an administrator. But whenever you do need to run something that needs higher permissions than what you have, then you can do what we're seeing here. Then you can do the sudo and then put in that password, because you would be a security analyst. You would know the sudo password. They would give it to you, but just tell you, don't use sudo to, the 8 hours that you're at work. Use your account, but when you do need the extra permission, use sudo. And then once you use sudo, then when you finish that task, it puts you back into CAN. And if you recall when I said if you go to a certain command and you do a right click, when you do a right click to run a program, one of the options in the right click is going to say run as administrator, and you click on that, and then it runs it as administrator. This is that in Windows is exactly the same process as what we're doing here with sudo, except that Linux is more command driven, and Windows is more GUI environment. But in Windows, again, the equivalent to this is you would go to the program you want to run, you see the icon, but instead of clicking the left mouse button, you click the right mouse button, and then it gives you a drop-down list. And one of the entries in that drop-down says run as administrator. And when you click on it, it will run as administrator. That's equivalent to this sudo. Okay, so let's see. Are we CAN right now or are we sudo? Well, I forgot. We got confused here. So let's just see. You can always say, who am I? And it tells you, what account are you operating under? Okay, we're back to CAN right there. But with sudo, we did the command and it pops us back. Yes, I want another 10 minutes. Okay, so now we know we're back to CAN. And so now run a groups CAN. So in IT, users are placed in groups, right? If you work for the accounting department, you probably belong to the accounting group. If you work for sales, you probably belong to the sales group, right? So here, let's just see, CAN belongs to what group? So let's just see here. What group or groups? So we do groups, CAN, and CAN belongs to all these groups that you see here. Okay, so this is the way just to check what groups you belong to. Now they want us to run the PS again to see what processes are running. So we do PS, and we can see those processes that are running bash is this command line we're working with right now. Okay, so they want us to run and make a note of the PID of the bash. Okay, if you can remember this, lady and gentlemen, 3389 is the PID in case it asks for it. 3329, because they want us to remember that. The PID of the bash process. I don't know if it'll ask for it later on. 3329. Okay, so now we're going to do sudo again and respond with, okay.
You can type 3329 in that box right under the.
That's what it's saying.
And then it'll remind you later.
Oh, good. Okay, good, Ari. You know this pretty well. Right here, see how it says run SU. SU right here. Well, SU is the same as typing in SUDO. In Linux, you can take shortcuts. There, if I would hit the tab, it would spell out the whole word. But anyway, I'm going to type in sudo SU, which is sudo, and sudo again. We're getting back into a higher level account, so I need to put in the password P right A $W 0RD, and then it got. Did I misspell that? Let me see. Let me try this again. SU. Okay, the password is PA $W 0RDO. They're repeating the password. See there? PA $W 0RD. And now it got us in. Yeah, and this they had the password was in there twice. Okay, and then press the up arrow key. Remember, the up arrow key will bring back previous commands. If I click the up arrow here, it brought a previous command. Press the up arrow key. Note that the command you enter as CAN are not listed. Okay. Now run PS and note that batch has a different PID. Okay, well, what happened here? PS and batch has 3523. So because now it's running a different process, the other process terminated. So again, we ran that. They wanted us to see that. Okay. And then run, who am I? Are we running under CAM or is a sudo? Or let's just see. Who am I? And I'm running a sudo. Note, see there? Y'all see that? That says ROOT? That's a sudo account. ROOT in Linux is equal to, in Windows, administrator. Root is the same as administrator, but Linux has their own wording other than Windows, right? Because it's not Windows. And then now, what groups does root belong to? Which root again is the administrator? Well, let's just see. Groups, ROOT, and again, that's what the result it gave us. Yeah, because pretty much root, you don't put the administrator in groups anyway. And then they want to run a list, ls. And then we're going to go into the boot directory, EF5, which is only should be accessible by sudo. Okay, it succeeded because we are logged in as sudo. If it was logged in as CAM, it would not allow us. Earlier, it did not allow us. Now we want to get out because we are done with that. So we exit out of it. And it took us out. And now we exit again.
Back on CAM.
What's that?
Once you ran exit, the username is CAM at home server.
Exactly. Mm-hmm. And then exit took us out of the terminal window. We say next. And now list the directory contents. Now let's just see what they want us to do here. Show hints. I don't know. Hints enabled, whatever that is. Okay. I guess it'll give us some help if we go through this. If necessary, from the doc, select terminal. Okay, let's do it again. Terminal. And then here they want us to do CED tilde to set the working directory. Okay, that's our working directory. And then ls minus rl redirecting to, okay, all this is caps, so it's home server.txt txt. So it directed an output to a file by name of home server. Now they want us to get back in as sudo ls minus rl direct to home server again. I lost my okay. Sudo. Oh, I think I got confused here. So sudo and then minus L and oh, sorry. Now we want to go to the etc directory. Server.txt, verify password P A W E. Okay, got us in. Check if necessary from the doc, select terminal. Where we are in terminal, If necessary, run cd to set the working directory to home. Okay, we are home/cam. We are in the right directory as well already, right? Home server cam. Oh, well, let me see. If necessary, well, let's just do this. Yeah, okay. And then now they want us to get a list of the contents of home server. 1 second here. All right, so here we are. Cat XT. All right. It shows the contents of what it placed in home server because earlier we directed output into that file. And now they want us to get out. Well, let me bust this out. You see a lot. We'll do a queue to quit as they requested. And then a check task completion. Let's just see here. When you have checked your work, select evaluate. Check task completion. I don't know. Here, check task completion, checking for hint use and checking for, okay. What is it doing? Evaluate there. And whatever it did here, we just don't need to use guided steps and hints while attempting the task. Okay, that's fine. Checking the retries. Okay, everything went well. Next. Now they have a quiz for us. Which of the following components implements an input-output interface between the user and the Linux computer's command line environment? So what do you think here, class? Which of the following components implements an input-output interface between the user and the Linux computer's command line? Well, we've been working with terminal, right? Keying in our commands. So let's go with that. Was it only one question or did it have, oh, it has more. What type of component is, what's that? PTS 0. Type of component, which we would just say, let's just say shell, because that's all we've been working with. Which of the following commands can be used to investigate the options available for a particular command? Man, right? Gives us some help there. I don't know, let's just go evaluate. Okay, cool. Next, great lab. And submit. Yeah, let's go ahead and submit. What the heck?
Good job.
Okay, so write the absolute path. Okay, that question I didn't understand what it was saying, but because of sake of time, I just hurried through that. But as you can see, we got past this, and I know, Eric, when you go to the library, just hopefully it'll get you through because again on yours it just would not work, right?
Yeah, because it worked just fine for you, but I had two separate issues. And I'm
And
wondering, are you using a desktop?
I'm using my laptop. Uh, let me just ask you: when you're working on the right side, and you check each box as you're going, and then when you need to do something on the left, you have to click your cursor on the left window. So you have to click your cursor on the left, if you're going to type something in the terminal, and when you have to do something on the right side, you have to click the mouse on the right side. Because
I believe I did do that.
Okay, maybe you did. I'm not.
But I will try. I'll see, and I'll try to give it another shot.
Okay,
But
yeah.
it was two different issues. The first time I was typing just fine, and then when it would get to the point of asking for the password, and I would be typing the password, it'll automatically like shut me off and
Oh,
say,
okay.
give
Yeah.
me some kind of error message. And then that's when I reported it. They said
Okay.
they couldn't replicate it. And then now it doesn't matter what I type into terminal, it just won't take it.
Oh, okay. So no, I'm sure you were doing things the right way. I'm just throwing things out just in case. Because here, when I was doing this and I was working on the right side, and I would go to a terminal and type something in, nothing would happen. And that's why I remember, oh, okay, let me come back and click, and then I would do it, and then I would have to go back and forth. But if you're doing that, yeah, your issue then again it could be something else. Uh,
I
and
mean, it could be. I don't, I would like to think that I was doing that because to me it's kind of like a common sense thing,
yeah,
but I don't, it's
yeah,
such,
yeah.
I guess it's such a small detail that
Yeah,
I
yeah.
can't really remember if I did, but I'm pretty sure I did. But
Oh,
I
okay.
can give it another shot. If that doesn't work,
Yeah.
then I'll just go find a library.
Because I know I did it several times today. I went over to the terminal and I typed something, nothing happened. I said, "Oh, let me bring my mouse over and click on it, and then it would work." And then when I need to go to the right side, I need to click on the right side. So again, give that a try. You just never know. But
Okay.
anyway, at least, and what we did today is like consider it as you had worked, as you guys worked the lab. You saw how it worked, and you know exactly how it works. So you were even telling me some other things that we have to do. It's
Right.
just
I'm
hopefully.
glad, and I just want to say thank you. I'm glad you did this with us.
Sure,
Um, I'm
absolutely.
not,
I wanted to do it because I know y'all, it gets frustrating,
but
but at least we got to do this one. Okay.
it does get frustrating.
So
But
now,
in order for us to get like, in order for us to get through that course and I guess get certification in the A+, we have to complete all of our labs and for each module. Is that correct?
uh, it, that is the ideal way. But in this case, if fish failing on you, uh, don't stress too much. Don't stress too much because it's not anything that you guys are doing. If it's not working for you.
Because I was
Okay.
gonna say I got 97% done. I'll take my 97 and I'll be done
Great.
with it.
That's good. That's good. Uh, okay, so I'm gonna go ahead now and stop the sharing, and I'm gonna go ahead and pull up today's lecture. Give me a minute. I gotta go connect something, and then I come back and pull that out. So you need to take like a 5 minute little break. Go ahead and do that. All right, class, let's go ahead and we're going to get half of module 6 today. Should go pretty smooth. So let's just see what that's all about. Module 6, implementing threat intelligence. Let's look at the outcomes. Let me make sure that the recording is still going. I didn't stop it. It should be going. Okay, so differentiate between threat actor types, right? The threat actors or the hackers, the bad guys. Compare threat intelligence sources. Identify, categorize, and explain indicators of compromise, abbreviated as IOCs, in network intrusion detection. Map threats to environments, and explain cyber deception and design basic deception strategies. So threat actor concepts, threat intelligence, right? So that develop insights into adversary group behaviors. We as security analysts always have to be aware of what threats are out there. That's why I'm saying if you subscribe to a cybersecurity feed, they'll keep you updated as to what's going on and also updated as to certain attacks and what's the behavior of that attack. So by us staying current with those, we can detect anything that's beginning to act abnormal, right? And an anomaly. Monitors nation state, organized crime, and hacktivist groups, right? So nation state or hackers from other countries that are attacking a different country. Organized crime, we know what that is, right? Organized crime as we know it, just the mob. And then hacktivists, right? And we know who they are. They are the people that are fighting for a cause, and they do hacks to get the attention. Evaluates adversary resources, funding, and sophistication. So again, you got to evaluate that. For example, nation state actors, threat actors, they have a lot of money because they're funded by the nation, by the government. And again, so if we know that they're nation state attacks, we know these people have a lot of resources. They have the funding, and probably sophistication because governments fighting with each other, cyber security methods. They're going to put in money into finding the most resources they can have to be able to be successful in their attack. And then opportunistic versus targeted attacks. Okay, so let's just see here. Opportunistic is what? Low sophistication, widely available tools. Okay, so there are some tools out there. For example, there's a password cracker tools you can buy. And it's a program that you run against other computers to see if it can guess the passwords, right? So those would be opportunistic. Well, they could also be targeted if you're targeting a certain system. And then you have the targeted, those are the sophisticated tools. And then you have the skilled professionals, and they have a budget. So these are targeted. These could be in the business world, competitors, are trying to be first to market and sell more of their product, right? So you'd be surprised that there's a lot of espionage going on within organizations that do the same type of business, because they're trying to find out the secrets of the competitors, so they can find out what those are, and they can incorporate those into their strategies and their processes to be first to market and have greater sales. So again, skilled people are the targeted ones. The nation states, as you can see there, they use cyber weapons for military and commercial goals. Okay, so cyber weapons, and again, they could target military installations. And again, they're not dropping bombs or anything like that. They're just trying to mess up the infrastructure. Think about the grid. We all depend on electricity. What if a nation state would attack our grid and all of a sudden we don't have electricity. And then how long is it going to take before electricity comes up? Is it going to be a day? Is it going to be a week? How long is it going to be? And what's the impact? Stop and think about it. What about hospitals that rely on having this electricity? So there's a lot of critical areas that can be hurt, hurt, H-U-R-T, hurt by an attack, a cyber attack by another nation, right? And again, they immobilize certain things, and then they could move in, physically and then drop the bombs. And what's another one? Often pursue espionage and strategic advantage, right? So the nation states, so they're performing espionage and try to get the advantage over the enemy. So insider threats, again, you all know what that is, right? They're very dangerous because they're already inside your network, right? They have access to resources already. Arises from actors granted some type of access, right? If it's an employee, they're going to have permissions to certain files and certain areas of your network. And again, if they decide to cause harm, they already have, an insight, a head start from an outsider. Includes permanent and temporary privileges, right? Because they have these privileges. What are those privileges? There are some controls that you can put that it could alert someone. We discussed that last class, where if a certain user has regular permissions, and let's say he has a friend that's one of the technicians, and if the technician escalates his permissions, and he's not supposed to have those escalated permissions, well, you could have some controls that would send out to the log file and specify, hey, this user has had his permissions escalated. Okay, and then that's going to raise a red flag, and you as a security analyst are going to look at the log and going to see that, and then you look at it carefully, and then you say, okay, well, yeah, this user got promoted. That is okay. That his privileges got escalated. But if you see, no, this user should not have extra permissions, right? So you catch that at that point. The supply chain threats, right? Vendors and products can expose secure environments. Attackers may exploit suppliers, services, or equipment. There was one case where the product, which was the computers, were built, and then through the supply chain, they were sent out to different parts of the country, to the warehouses for the company. And then once they're at the warehouse, from there, they begin to distribute to the retailers, right? Well, somebody broke into the warehouse, got into those computers in the warehouse, and they infected those computers with viruses. So then these computers go to the retail stores, and now they're being sold at the retail stores, and they're brand new. But, that's pretty bad that you're buying a brand new computer, you bring it home, it's already infected with a virus, right? So these are some of the things that can happen through the supply chain, which goes from point A all the way to point B. But what are the intermediate points? Are they safe? So again, attackers can exploit the supply chain. Okay, you have the advanced persistent threats, which are persistent threats are threats that are still there, that you haven't cleaned them enough that to eradicate them completely. So again, APT describes advanced adversaries and the tools that they use. Detection includes command and control software and unusual activity. So the command and control is where some hacker has a central computer, and from that central computer, he's infecting many computers as he's able to break into these different networks and infect the computers. And then those computers, the infection that they receive is called zombies. And these zombies are controlled by the command center, by this central computer that this hacker has. And he could tell the zombies, stay dormant, don't do anything. and let's say July 4th, wake up and do your damage that you've been programmed to do. That's an example of control and command center. And again, this is a distributed denial of service because it's distributing these infections to many computers, but they're not doing anything. All he's doing is planting the infection, but he's not activating the damage yet. But then he does it with the control center when he decides he wants the attack to start. Then you have the anti-forensics. It's a defining, again, a persistent characteristic that hides a lot of the evidence from an attack. And then what are the goals of APT, of the Advanced Persistent Threat? Political objectives. Okay, here again, it could be dealing with politics. And in politics, you have opponents, right? Espionage. We talked about espionage between companies. And then long-term access, having long-term access because they're undetected. They're persistent. The infection is persistent. The company infected did not eradicate it, and it stays there, and it's doing whatever it does. And then you have the custom exploits support persistent and stealth infections. So again, stealthy means undetected, and then often target large organizations with valuable information. If you're going to go to that extreme to do the persistent threats, it's because there's some value there. Small players, there might not be too much value there. Expend all that energy in infecting with APTs. So you go for the big fish, as they say, and where you can get some value out of there. A lot of it is for monetary purposes. And then carefully planned attacks may unfold over months or longer. Again, this in the command and control center, the guy could be planning these zombies for 5-6 months, and then he could wake them up in months 7. And by then, he has thousands of these zombies planted in thousands of computers. So again, these guys are very technical. They know exactly how to go about doing this. Okay, the other one is they call them TTPs, tactics, techniques, and procedures. So the TTPs describe how threat actors conduct attacks. Okay, so it's good for us to stay abreast of the different attacks and how these attacks are conducted, because then you can be watching your network and making sure, hey, that type of attack is out right now, and they say it comes in through the firewall, so let's monitor our firewall very carefully. Analysts document methods to fingerprint adversaries. Fingerprint just means the techniques that they use. That's fingerprinting. The behavior of these type of threat actors. That it's like you're building a profile of how they conduct themselves. To perform this intrusion, this attack. So TTPs help prioritize the defenses and associate attacks. So again, by knowing the profile and the characteristics, you begin to enforce more of your security controls to prevent that attack that's out there at that moment. So the MITRE ATT&CK framework, this is a framework that has a lot of advice and recommendations as to how to protect yourself. The attack maps actions to tactical objectives. So if you go to if you Google MITRE ATT&CK, it has a framework and tells you how to protect yourself. So it's work. All this has already been done for us. We don't have to reinvent the wheel. They will tell us exactly how to protect ourselves. Whatever type of attacks, they say this is the way you should be putting in the security controls. Helps track, identify, and counter methods. It's a great help for us security analysts, to frequent that site every time we have to go and be diligent on our network of knowing what current attacks are or navigating the internet at that moment, at that time. And then attribution, links observed TTPs to a threat actor or ATP. So again, it links whatever you've observed to those techniques, and then you may detect, okay, this is one technique that they use. I'm noticing that we're getting a lot of emails with these web links. Okay, that could be their technique, and you begin to identify that type of attack because the behavior is matching. Connects what was done with who did it. Okay, and then uses evidence. It will track. It will capture evidence and the mapping of how they navigated through your network, and then that type of behavior. They're already known profiles by these agencies that all they do is combat and learn about security attacks, and they post that out there in the security feeds or in the MITRE ATT&CK frameworks, and they tell you, exactly what you need to know for specific attacks. All right, class. We're gonna cover the last two things, the pyramid of pain, and then at this point we'll conclude the lecture so that we can leave the last part of this module for Saturday. I don't want to get too far. I did email Mercy. I haven't gotten a response yet, so hopefully within the next few days we'll get something as far as our cert master. But anyway, let's look at the pyramid of pain. Prioritizes detection and threat hunting efforts, right? So you got to prioritize your detection. You got to catch that intrusion immediately because you got to mitigate the damage. If you don't catch it till days later, no telling how much damage they could have caused. So we got to do threat hunting. We always have to be looking at our network. Lower levels are easier for attackers to change, right? The lower levels is the easier ways that they can get in. Higher levels can disrupt attacks more effectively, right? So again, because you would have the stronger security controls there. And then 6 levels of indicators of compromise. The hashes, remember yesterday's class, we talked about hashing. IP addresses is something we can look at. If they're IP addresses that don't belong on our network, there's an intruder there. Domain names, network and host artifacts. Artifacts are evidence left behind. And then you have tools to help us detect these things. And then the TTPs as well. So let's look at the pyramid and see the explanation. Here, the higher you go, the tougher it is. So if we start at the bottom, trivial hash values, recompile the malware, and you may get some evidence there. The easy IP addresses, switch servers, right? So the IP addresses will tell you if it's an IP address for your servers or of different systems on your network. Simple, those are the domain names, replace at no cost. Again, so the pyramid of pain, I guess, is they're talking about what pain are they causing you. The trivial is little pain you can recover quickly. IP addresses, again, if they're tampering with that, you can always change the range of IP addresses in your company. You say they tampered with addresses starting with 192. 168. So we're going to change our address scheme now to 172. And then the domain, again, replace at no cost. And then the other one is annoying network and host artifacts, modify artifacts with difficulty. And then the challenging says change tools with significant resource investment. Okay, so there are some tools that can go in there and start changing things, but it's going to cost money because these tools are not cheap. They're expensive, but if you need them, you need them. And then finally, the tough TTPs, retrain entire team and rewrite playbooks. So extremely resource intensive. If you have to change your whole environment to avoid hackers that already know about your network, you can do it to protect your network, but it's like you having to redo everything and change everything involved. And yeah, you'll be protected, but they've cost you a lot of pain, a lot of work to be able to transition from one setup to a different setup. So that is the pyramid of pain. And this is a really good stopping point, class, because I want to just elaborate still a little bit more. Uh, but you've had enough information today to start thinking about implementing threat intelligence. This is about us being abreast of the latest attacks that are out there and the profile of the attackers and the techniques that they use to break in. So we know these things. We know how to start protecting our network and what to be on the lookout for with the behavior of our own network. Because if it's behaving differently, and we can link it to the pattern of the attack, then we can pinpoint what type of attack it is, and so on. So at this point, class, let's go ahead and conclude the lecture, and we'll wait on getting the cert master. Hopefully we'll get it tomorrow. Yesterday I mentioned, I said I didn't give you material to work on because I was hoping that we had the material today. But what I'll do today is I'll look for a couple of things for you to work on in case we don't get the material tomorrow. But I'll send you something tomorrow for sure, as far as any assignments for you to work on. If you have questions, class, I'll answer them for you. If not, let's go ahead and conclude lecture, and let's go ahead and break for lab. And I will stay on till 10. If you have anything in the chat you want to send me, I'll be on. It will take me 10 minutes to switch over, as I always do. And we'll go from there, class, and we'll be a few days without touching base, but Saturday we'll see you again. I'll stop the sharing. Stop share.